We're going to demonstrate here how the Fuse Drive software can significantly improve the MySQL database performance in a Windows 2012 environment. Now this will work equally well in Windows 2K8 R2 or 2016. And what we're going to see here is how well or easily the Fuse Drive can upgrade the disk drive on the current system without having to migrate the database. So with that, let's get going. So we're going to be taking a test MySQL database in this case. We've already pre-configured this to be running with 8 users. You can see from the Workbench connection, this is a Windows 2012 remote connection window here, or remote connect window, and here we're connecting from my client desktop via MySQL Workbench, just to see what kind of performance we're getting out of the system right now. We're seeing about 100 to 230 SQL statements executed per second. We're running off a single disk drive, so it's not tremendous here, but it certainly is useful just to see what the baseline is before we go ahead and upgrade this to Fuse Drive. And here's our database here, just sitting on the drive as TPC-C 1 in this case. So I'm going to go ahead and stop the database, because the first thing we're going to want to do is import this disk drive into our environment. Now note, we're not going to copy anything off or back it off, even though we recommend you back up anything when you're making changes to your system for any number of reasons. Things can happen. So we're going to first of all just stop the MySQL. I'm going to just close down the Workbench, because I find when you do that sometimes you lose sync. So we're just going to shut down the connection here, and let's just go ahead, and the first thing we're going to do here is convert the disk drive 5 to create a single tiered drive. The purpose of doing this is just to bring it into our environment. You can go straight to a tier, of course, with this as well, but this I find is the most convenient way, just to first of all bring it in. So it's recognized we already have a partition. Of course, we want to keep that partition, and it's going to temporarily take it offline while we import it into our environment, and then of course bring it back online. Now we're not tiered at this point, we're not fused, we're not really doing anything other than just putting our metadata on the drive and kind of juggling it around, so we're in our virtual SSD format. This is so we can very easily allow ourselves to go ahead and add an SSD later. So if I look over here, our D drive is certainly back and alive, all is well. But the difference in this case, if we look at the list function here, is you're going to see we now have a drive 6 here. And drive 6 is now where our D drive actually resides. And you can confirm that with a quick look at disk management as well. It'll also just confirm for you that the disk 5 drive, physical drive, is now offline, and the disk 6 is our Enmotus Fuse drive, is now the primary owner of the D volume. Now the nice thing there, of course, as you notice, is we did not have to copy all the contents across or change any of the file permissions, etc., etc. We just had to really quiesce the system. Now once we've done that, let's restart up our MySQL database here. Let's reconnect ourselves up here on the Workbench, and what we're going to do is just do a quick sanity check that we can still run. So here we go, we fired up our database, and you're going to see no difference here initially. That's because we haven't added our SSD yet, but we've got ourselves in the state when we're ready to add the SSD. Now the nice thing about the Fuse Drive software, this is in the version 2 or higher, you're going to be able to live add now any one of those 2 SSDs that we saw earlier, drive 1 or the other one, which is a drive 3. We have 2 spare ones here, so I'm going to use drive 1, and then you can also remove it, all while the system's running live. So I'm going to illustrate that now to give it a little chance to kind of warm up here in the disk drive level, and you can see you get a little bit of a boost already from having Fuse Drive from the queuing system and mechanism we put in place, but you're still pretty much running at your hard drive levels. Now what I'm going to do is convert over while it's running. Nope, we haven't stopped any of the tests running here. We're continuing to run, and we're going to do a convert, and I'm going to take drive 6, and I'm now going to make it tiered Actually, sorry, we're going to do one step first. We're going to create our fast tier device, which is basically creating a V drive. We call those V drives the intermediate tier disk here from drive 1, just so we have something that we can now add from the command line here. You can also use the econfig utility, which actually allows you to skip this step. But it's sometimes useful for people to see how we can create this intermediate disk here. So if I now just list in the system, we find we have a V drive that's not actually connected here, and we have a T drive which only has one component to it right now. So let's go ahead and change that. Let's now convert our drive 6, which is our system drive here, drive 6 Enmotus, to a tiered volume, and we're going to be using V drive, the number you can get from here, 1. So you can see V drive 1 will now attach drive 1 to this while we're running live. So yes, I do want to convert, and it's now going to go ahead as we're continuing to run to convert the system. That's done. So now we've added our SSD. Now a few things are going to happen from this point on. The SSD and the auto tiering and the auto analysis and all the various nice things you have with the fuse drive now start to kick in. And of course, what you can also see is the the actual spatial behavior of what's going to start happening here. And if I blow this up for a second, this is the eLive monitor. We've already started to detect in our activity zone that we've got active data. We're going to start pulling this new SSD portion we tagged on the end of our disk drive currently out of the way, so we can preserve our existing data, but it's going to start pulling it down to the area here, which is where we're actually using our disks. So initially you're not going to see any major changes while it does this and starts going through its changes. We'll leave that just running here. But what you are going to see is as we improve here, you're going to start seeing a dramatic improvement in the performance. Now I'm going to speed it up a little because right now the priority is set to give priority to the host IOs. Even though we're starting to see a gradual incline in the performance, what's usually useful is to just give it some breathing room. We're hammering this thing pretty hard right now. In reality, your database isn't usually going to be going that hard, but if it is, it's just going to take a little bit longer to get up. So you can see already we're kicking up to the 1K kind of level. So I could choose I guess I could choose here to pause it, but I'm not going to do that here because it seems like it's already started to kick up in performance. And here you can see, we zoom in on this a little bit more as well, you can start to see how more of the SSD is being pulled down to the region that we wish to, of course, be applying to SSD rather than just sitting on the hard drive. So a couple of things. Note I have not taken the thing offline here, and it's been behaving reasonably well throughout this whole transition. Workbench has showed that we're still running our database. Of course, that initial step of converting it to the fuse drive was the only time we really had to stop and quiesce the system, but as you can see, that took very little time to convert on over. Restart your database and you're up and running. Now another nice thing while we've been talking here, you can see that our performance is also reflected by the Enmotus utilities running on the server itself. We can start to see how the number of IOs per second are steadily shifting from the cold tier to the fast tier. This is the point where we made our transition here, very heavily HDD oriented, and then of course as you start to see here the transition taking effect, more and more of the data is going to be moving up to the SSD tier. And again, this is not cache, this is actually moving it to the SSD tier, so you're going to get the full read-write performance and read-write benefits going on here. So eventually what's going to happen is, if we were to watch this over a longer period of time, you're going to see this gradually go to 0 on the cold tier, as it were, and the hot tier is going to continue to improve in performance. So we're already now up to 2K from the original 170 to 220 we kind of started with. Then we went to kind of a 3 level when we converted to the fuse drive. Now note, we're not running RAM cache here on our tier, we're just running pure tiering. The configuration is just a straightforward SSD hard drive combination. And what we've shown here is the ability to really easily, as you can see, in less than 10 minutes here, we've been able to go through and just convert the whole of your system to an SSD class system without, removing your data, without backing it off to a different drive and restoring it, etc., etc. And in future tutorials, we'll be able to show you how you can actually remove this SSD in just the same manner we've just done here without taking anything offline. And if you have like an NVMe drive you've added, you can go ahead and give yourself a faster, even faster system if you wish. Okay, that's it. Thank you.